O. Morgan Labs, Physics, Gravity and Orbits. A starship observes a Class M planet orbiting with a period of 2.44 times 10 to the 5th seconds around a star that is 1.8 times 10 to the 33rd kilograms. Find the distance between the star and the planet. Two-step procedure. Step 1 is identify the key unknown. What is your question asking you? Step 2 will be what concept or equation links your known and unknown variables. Step 1, our key unknown is distance. R, we'll call it. Step 2, the question is set up, okay, we're talking about things in space, planets and stars orbiting. You're thinking about orbits, and that makes you think of Kepler's law. And it has our unknowns, our R unknown, period, and then there's a constant here that can be derived later. But this is the equation. Now let's think about this. How many knowns do we have? We know T, we know K, we don't know R. So that is one unknown and one equation, so we can solve it. You really don't have to do this a lot when you're in school, but when you're out in the real world, questions are kind of open-ended and you have to figure out, okay, do I have everything I need to solve this problem? Okay, let's keep going. K. This is another part that makes it kind of difficult. Sometimes you have your primary equation and then you have these little secondary equations that kind of fill in the other equation. That's what kind of makes it kind of difficult sometimes. But if you think of the key unknown and your key equation, that can keep things organized in your head so you don't get so confused. We know pi, 3.14, that's just the same pi that we've been using forever. G is your Newton's gravitational constant. M is your mass of your center body, your star, the thing you're revolving around. Not this mass, okay? The center body, the thing you're revolving around. We plug in, G is 6.67 times 10 to the minus 11th Newton meters squared per kilogram squared. The units are important. Working out units helps you check yourself. Because sometimes you may be tired or going through the problem real quickly. And if your units don't work out, something's wrong. You didn't convert something, you didn't do an algebra step correctly. The M is 1.8 times 10 to the 33rd kilograms. We plug everything in and we get K is 3.29 times 10 to the minus 22nd seconds squared per meter cubed. Now, algebra step. We want to isolate R cubed. So we move the K to the left-hand side. We're multiplying K times R cubed, so we do the opposite. So we divide by K. That's what we do here. We divide both sides by K. And we get 1.81 times 10 to the 32nd meters cubed. I should have meters cubed like right here, equals R cubed. Next step, algebra step. To get rid of this 3, you have to think, okay, we're raising it to a third power. So the opposite of raising something to a power, you do the reciprocal. So we take 1/3 and get rid of that cubed on the right-hand side. And we get 5.66 times 10 to the 10th meters. This number is well and good, but a lot of times in astronomy, things in space, we use AU. So it's 0.38 AU equals R. AU, an astronomical unit, is the distance from the Earth to the sun. So now you have kind of a better feel of how far this object is from the star. It's almost like 1/3 the distance that the Earth is from the sun. All right, that's it. Hope you learned something. Like and subscribe. Keep studying, keep moving forward. O. Morgan Labs.